Next, you have the correction factor. This would be the last term lah that you will learn from this chapter. Okay. Log mean temperature difference, LMTD. Still under LMTD lah. It's a correction factor. Okay. So if you have this kind of heat exchanger, okay, you call it cross flow or multipass shell and heat tube exchanger. Okay. So cross flow ni macam ni. Ni cross flow. Okay, there are two type of cross flow lah. Sama ada single pass cross flow, okay, unmixed, okay, and single pass cross flow, one fluid mixed with the other unmixed. Ni saya pun tak tahu juga dia punya tu detail dia. Kena baca lagi lah. Okay. Tapi dia punya simbol ni dia tak ada, dia stripe dia. Yang ini dia ada macam grid kan. So this is two types of cross flow. This is two type of shell pass. Okay, shell pass, tube pass, shell or tube pass. Okay, maksudnya one shell pass boleh jadi 2, 4, 6 dan sebagainya. Any multiply of 2. 2, 4, 6, 8 dan sebagainya. Okay, so 2 shell pass ada 2 dan 4, 8 multiply of 4. Okay, so you have to be, they will give you what is the type of heat exchanger, whether it is cross flow ataupun shell pass. Okay, kalau then you will refer to ni lah, what is P, what is R. Okay, what is P, what is R. Okay, so P tu is T2 minus T1. Okay, T ni is tube. Nampak tak yang tadi terangkan tadi? Tadi your punya calculation data T log mean in based on TH ataupun TC kan. This time is location based. Okay, tadi tu condition based. T sama dengan shell. Tak kisahlah shell ke ataupun outer ke, whatever lah. Maknanya T ni besar lah, shell ni lagi besar daripada tube kan. Tube ni kecil. Contoh macam tu lah. Okay, so bermaksud 2 tu, 1 tu maksud inlet lah. 2 adalah outlet. Okay, so T outlet, okay, T tube ni, tube outlet tolak tube inlet, tube shell inlet tolak tube inlet, okay, dan sebagainya lah. Okay, P dengan R ni, itu je beza dia. Okay, so bila you dah kira P berapa, bila kira R berapa, then it's time to determine what is F. Okay, so F is yang ini, kat sini ni, dekat Y ni. Okay, so this one is P. Okay, yang ni P. Okay, kat X ni P. Dan yang curve ni is R. Okay, so bila you dah kira P, let's say P dia 0.6 lah, let's say. Okay, then R dia mungkin 1. So you boleh unjukkan je lah. Let's say dia punya tu is 2 shell pass ni. So dia unjukkan kat sini, then you unjukkan kat sini, then this will be the, let's say 0.87 for example. So R, F is 0.87. So F masuk kat sini 0.87 to compare with data T log mean cross counter flow, bukan parallel, counter flow. Okay, so correction factor is the factor that relates LMTD, okay, of the counter flow type of heat exchanger, okay, with multipass and cross flow heat exchanger lah. Tadi tu yang ini so dia nak mimic to counter flow tu. Okay, and of course the number will be 0 to 1 lah. Okay, kalau 1 is counter flow type. Okay, and then in order for you to have efficient design, you need to have the value of 0.75 or 0.8. Dia mesti lebih daripada tu. Okay? Dia mesti menghampiri kepada counterflow lah. Okay? Dan you punya feasibility lebih tinggi. So while using graph tadi tu. Okay? So your punya calculation normally dia macam ni kan. Okay? And so for correction factor, with correction factor, it will become Q U A S F delta T log ni. So ada sebutan F ni. Okay. So dia ada sebutan F. If F is equals to 1, so dia become ni lah. Counterflow. Okay. So of course, bila F ni is basically kurang daripada 1, of course dia punya Q dia akan berkurangan berbanding dengan counterflow. Okay. So that is why F ni should be menghampiri kepada counterflow, because the fact that Q will be as much as counterflow. If it is near 1 lah ataupun 1. Okay. That is the aim of the exercise. Okay. Okay, there is also a numerical calculation formula that can be used to determine F without looking at the graph tadi. Okay. You can use this formula. Okay. But it's quite complicated formula because you have to determine P and R just like the previous approach. But instead of using tube ataupun shell tadi tu, this one are using TH dengan TC. So you have to be very careful juga lah kat sini. Okay. And then they introduce another term which is X, which related to ni shell side pass. This one I think is much more related to ni lah, shell pass sebenarnya. Okay, rather than crossflow lah. So dia nak tahu shell side berapa, adakah 1 atau 2, itu je. Okay, kalau 1, N ni 1 lah, kalau 2 is N ni 2 lah. Okay, and this will be the formula to compute for F. You can get it by calculation without graphical. Just now this one is graphical. Okay. Or you can alternately, you can go for this formula. This this Excel calculation. Okay. Silah. You pergi kat situ this is the ni. So call macam calculator lah. You ada TH apa, TH2 apa, TC1 apa, TC2 apa, shell side berapa, so you akan dapat correction factor dia berapa. LMTD berapa, corrected LMTD berapa, dan PRX juga. Ni dah siap calculate lah. Okay. Dia dekat sini lah, kalau kata nak pergi, you boleh pergi kat tadi, website tadi tu. Okay. So ni Excel daripada website tu lah. Ni mudah lah, ni boleh kira terus. Okay. Tapi you have to be very careful lah. Okay. Sometimes dia terbalik lah, apalah. So you just be very careful. Okay. So kalau nak lebih accurate, you can use this lah because they are using calculation. Okay. The problem with this one, with the graphical, is basically you need to some sort of macam kalau you ada figure yang besar, lebih bagus lah, you can easily estimate it because dekat sini kalau katakan dia punya point dekat sini kan, so So it's not easy to ni kan, nak unjurkan dan sebagainya. So you will have a problem lah, okay, in determining the exact value, okay, rather than ni daripada ni lah, dan ni lebih tepat dia punya nilai tu. Okay, itu je lah. Okay. But don't worry about that lah. Kalau dalam final ke, if this question ever being asked in the final, you punya estimation tu is always valid. As long as, kalau kata kat sini lah dia punya tu janganlah you mestilah dia lebih daripada 0.9 kan. Okay. Let's say lah 0.93. So okay lah, can be accepted. Okay. Dan tiba-tiba dia punya point dekat sini, dia punya nilai 0.8. Tu salah lah. Okay. So I have my own judgment and consideration on that. So don't worry about that. Okay. So in return, this particular method, you are prone to or tend to make mistake in terms of calculation lah, because it's quite complex calculation. This one mahu banyak kurungan you kena pakai ni nanti. Okay, or else you have to do one by one lah calculation. This one start by this line dulu, then this line, then bagikan, and then you times with ln ni, and then you bagikan ni juga, lepas tu ln lagi, lepas tu ni bagi ni lagi. So it's quite tedious ni lah. It's basically plus minus je sebenarnya kat atas dengan bawah ni. Okay, so it can be very confusion lah, and you tend to make mistake lah from that. Tapi that is why ada yang Excel tadi yang saya tunjuk tadi tu. So basically you boleh masukkan nilai je terus dapat jawapan. Okay, calculator lah tu. Okay, yang tu confirm betul lah, memang formula dia memang akan betul lah, confirm. Okay, this will be the last calculation example. Okay, for calculation, which combine the theory of just yang tadi saya tunjuk tadi. First tadi, only factor kan, tak ada soalan dia kan, tak ada dia punya tu. So they combine into this example, both for only factor and correction factor. Okay. So just now, kalau untuk correction factor tadi tu is related to the value of driving force. Maksudnya we are talking about ni, this one. Just now untuk falling it's related to R. Okay, so correction factor is related to delta T. Okay. So, maknanya ataupun driving force lah. Itu beza dia antara fouling dengan correction factor. Okay. So fouling ni memang kita nak dia rendah, correction factor ni kita nak dia tinggi. In order for you to have Q tinggi. Itu je. Okay. So 2 shell passes and 4 tube passes. So dia tahu dah kalau 2 pass 4 tube ni, kita akan refer kepada yang mana? 2 shell pass, 4 tube passes. Yang mana? A, B, C, D. Balik. 2 shell passes, 4 tube passes. A, B, C, D.
B.
B B betul lah tu. 2 shell passes kan. 4 tube passes. So we are referring to B. Okay. So kita tahulah bila referring to B, kita tahu kita kena compute for R and compute for P. Okay. So but we have to ni dululah, extract the information dulu. Okay. Okay, sekarang ni heat exchanger is used to heat glycerin, okay, from 20 to 50. Okay, from 20 to 50. Okay, so maknanya kita boleh kata this one is ni lah, cold stream lah. Okay, nak heatkan dia kan. Okay, so which enter the thin wall 2 cm. Okay, tubes at 80 degree C and lift at 40 degree C. Okay, dia dah bagi dah T1, T2, T1, T2 semua dia bagi dah. The total length of the tube is 60 meter. Dia bagi L dah. Okay, so AS tu dah boleh tahu lah. Okay, AS ni is equals to pi LD. So L dia dah bagi 60, D dia dah bagi 2 kali 10 kuasa negatif 2 dan darabkan dengan pi. So dia dapat AS. Okay. The convection heat transfer is 25, okay, on the glycerin and 160 on the water. Okay. So of course lah HI berapa, H0 berapa. Okay. Sebab you nak kena bahagikan tu. Okay. Determine the rate of heat transfer in before falling and after falling. Dia kata falling dia 0.0006. Nampak kecil kecil gila. Okay. So apa jadi pada Q dia? Dia nak Q ni, dia nak ini. Okay. So memang you kena ada F ni lah. Okay, sebab dia 2 shell pass and 4 tube pass ni, F ni memang kena ada, wajib ada. So yang menentukan nanti adalah U. Okay, U ni without fouling and after fouling. Dia ada 2 senario lah. Okay, A sebelum fouling, B after fouling. So A tu no problem lah, you jangan pertimbangkan ni je lah. Okay, so before fouling, yang ini saja. Okay, dia dah ada bagi dah H apa semua. After fouling, you tambah je terus dengan R ni terus tambah je, and you are still considering yang tadi tu. Okay, maknanya dia negligible lah dia punya wall tu, sebab dia tulis kat sini thin wall. Okay, thin wall so because of thin wall tadi tu, you end up dengan this equation lah. Okay, dan B tu tambah je R. Okay, cumanya dia akan jadi problem, bukan problem apa, maksudnya U ni tak ada masalah, you boleh dapat senang je calculation dia. Data T-log mean ni je yang susah. Okay, sebab dia panjang sikit lah, bukan susah pun, dia panjang. Okay, because you have to determine what is TH, what is TC, out, in dan sebagainya. Okay, so make sure lah. Kalau hot tu maknanya dia punya kesudahan dia adalah suhu dia turun. So hot water ni, okay, suhu dia tinggi, tapi bila keluar suhu dia turun. Cold ni suhu dia rendah, bila keluar dia naik. Okay. Cold ni to be heated lah, hot ni to be cool. Okay, so kena ingat tu. Okay. Maknanya hot, kalau dia panggil hot tu is basically T1, okay, mesti lebih tinggi daripada T2. Kalau cold, T1 mesti lebih rendah daripada T2. Okay. Ingat je, hot is something to be cool, cold is something to be heated. Itu. Okay. Dia mesti bertentangan lah. Okay. Once you dapat data T-log mean, memang ada lah. Okay. You kena darabkan juga akhirnya. Dan you kena dapatkan P, you kena dapatkan R. Then you akan dapat F. Okay. And then 2 nilai ni, 3 nilai ni, termasuk A ni, memang akan ada dah. You kira F tu. Okay. So it's just that you kena masukkan U je. Sama ada you pakai yang ni untuk A, dan plus yang RF0 ni untuk B. So the answer would be, without falling, your Q is 1830. with falling, your Q turun jadi 0.5. Okay, maknanya dia turun 25 watt. Okay, so you dah kehilangan 25 watt dengan fouling factor ini je, 0.006 je. Can you imagine kalau you have a bigger fouling factor, so you will have a bigger loss lah in terms of Q. Okay, so that would be the conclusion lah from this exercise. Okay, so macam tadi lah. Okay, first tadi you cari yang tadi 3 tadi, then last kali baru cari U berapa. Okay, so please try ni lah, this at home. Try this at home. Okay, we spend time to do this example. Okay, but if you find that this is quite small, maybe you want to copy this chart and maybe you want to enlarge it lah, so that you can new this one lah. It may be much more easier lah kalau you boleh ni kan or else you boleh juga pakai this formula pun boleh juga. Okay, tapi not really reliable lah, takut you confuse je. Okay. It will result in the same the same F lah, more or less the same F. Okay. So give it a try lah for this particular example. Alright, last slide of the semester. Selection of heat exchanger. You have to look at the heat transfer rate. Okay, accommodate the heat transfer rate as per required. You have to look at the cost of installation. How big is your capacity of your processing area? Okay, operation wise and maintenance wise, how do you want to abandon or do you want to scrap off? Okay, and then you have to look at the elevation of your process, whether you need the pumping power, okay, W, okay, which correspond to the operating cost because you have extra power of pumping power. Okay, yes, you have to minimize delta P and flow rate. Okay, and size and weight. Okay, we have special heat exchanger for automotive or aerospace because of the size and weight punya problem lah. Okay, and type, okay, depends on type of fluid, size and weight and phase changes. Materials, in terms of the capacity of that material to contain that particular fluid, and also that material with regards to normally the one that is important in the material is the conductivity, thermal conductivity, okay, as it will somehow have impact on the Q, okay, the calculation of Q. You have other considerations such as safety and also reliability, okay, whether your system is quiet or not, okay, sebab ada certain will produce high pitch dan sebagainya, so dia akan beri problem pada in the long run lah. Okay, so and so on and so forth. Okay, so other consideration also be included lah, is one of the selection of heat exchanger criteria. Okay,